Now let's go ahead and write the Java logic for finding the nth root of a number. So here, according to the algorithm that we have discussed, we will be deploying the binary search based solution, right? So here, whenever we talk about the binary search based solution, what we will have the left pointer and we will have the right pointer, and we will basically calculate the middle, and based on the nature, either we return the middle value or we restrict our search to either left part of the search range or to the right part of the search range. So here what I want to do is, first let me just define left. This I will be initializing with 1, and similarly I need right. This I will be initializing with the value of m. Why? Because I need to find a number such that if I perform that number power n, I should basically get m, right? So the maximum value that we can, it can go till the search range is that it is equal to the value of m. That is the reason why here, the value of the right that I have passed is equal to m. Okay, once this is done, I also want to define one variable called mid. I am initializing it with -1 now. Immediately what we will do, as long as left is less than or equal to the right that we have got, immediately we will calculate the middle. Middle is nothing but left plus right divided by 2. Once we have this middle, then we will basically calculate the middle power n. If that result is equal to the m, then we have found the value which is nothing but m, and we can return that. If not, we will limit our search range to either from left to middle -1 or middle +1 till right. So here the next step is to calculate the result, right? So for that, let's just employ math.power, and here let's just pass the middle, and I also want to pass the value of n. Okay, and it will return the result, right? Let's just store it in one variable int result, and it will basically return the double value. So let's just use the double itself. And once we have that, what we need to do, we need to compare the value of m with the result. If at all both of them are equal, we will directly return middle itself, because that is the nth root of the number. If that is not the case, there are two possibilities, right? Either the value can lie on the left part of the search range or on the right part of the search range. Here, if at all the result that we have gotten is greater than the value of m, in that case we need to find the value in the left part of the search range. That is the reason why here what I want to do is, I want to update the right to middle -1. Okay, if this is not the case, obviously we will have to find the appropriate value in the right part of the search range. So here immediately we will update right equal to middle +1. Okay, if at all any number matches, we would directly return that. Otherwise, once this loop execution completes, in the end we will return -1, indicating that there is no nth root of the given number. Okay, so that is the implementation. Now here to test this, I have passed 4 and 82, right? For these numbers, I am pretty sure that there is no number to which if we perform power 4, we will basically get the result 2. So ideally, I should be getting -1 as the output. So let me just go ahead and run this logic and see the output. So it looks like I haven't saved some file, so I've gotten that. Anyway, if I try to rerun the application, and let me just expand the terminal here, I'm not getting anything. Why am I not getting anything? Sorry, here the issue is we need to update the left to middle +1, right? That is the reason why I think it was going on an infinite loop. So if I run this application once again, see the output that we have gotten is -1. Okay, just a variable name mismatch that I have done. That is the reason why we were not getting anything, because it was running on an infinite loop. Anyway, now if I just modify this to 81, 3 power 4 is nothing but 81. Why? 3 into 3 is 9, 9 into 3 is 27, 27 into 3 is nothing but 81. So I should be getting the result as 3. So let me just run the application, see the output that I have gotten is 3. Okay, similarly, let's just assume I have passed the value 3 and here I have passed 8. For example, we know that 2 power 3 is nothing but 8, right? So output should be 2. So let me run this application and we have gotten 2. If at all the value of m we have passed is 100. Now the output should be 10. Why? 10 power 3 is nothing but 1000, right? So let me just pass it as 1000, and if I run this application now, the output is 10. If at all I pass only 100, there is no integer to which if we perform power 3, basically that will yield a result of 100. So if I run this now, ideally output should be -1, and -1 is what we have gotten. Similarly, in the same fashion, you can pass any value for n and m based on whether it has valid nth root or not. You will either get the valid result or -1 as output. Okay, so that is the optimal way for finding the nth root of a number using binary searching technique.